Hey, good morning, geometry. It's Maze coming at you live from room 308. It's Monday already. Yay, it's the 27th of April. Time to get up and get cracking on them circles. Today, I would like to show you a generic use of the law of sines that kind of goes along with your check for comprehension. Several of you, not only do I question your geometric comprehension, but I also question your algebraic comprehension. So just to make sure we're on the same page here, I'm going to show you the law of sines on how to find the length of those sides. So what I have here, I drew up something in GeoGebra. I just made a random triangle, and we're going to show you how to use the law of sines to find the length of the side. So here we go. So there's my triangle, all right? Now notice what we're given. We're given the measure of two angles, which you have the measure of two angles. You start off with an L minus, or an angle minus L and an angle plus L. So you have the measure of all three angles. And you also have the length of one side. In your case, it's a 10. All right, now this is what we have here. So I'm going to find the length of AB. To find the length of AB, I'm going to use the law of sines. So notice what I have. I have a 56.31 degree angle opposite a length CB of 13.93. I'm going to find the length of AB, and I have the angle opposite AB, 57.65. So when you set this up, this is what it looks like. So there you go. To find AB, use the law of sines. A over sine A. In other words, the length of the side opposite angle A is equal to the length of the side opposite angle B is equal to the length of the side opposite angle C. We have a pair. We have angle A. We have the measure of its opposite side, CB, which is 13.93. See that? The length of the side opposite the angle. Length of the side opposite the angle. All right, so we have that. So 13.93 over sine 56.13 is equal to AB over sine 57.65. Multiplying both sides of that equation by sine 57.65 will give us the length of AB. And you jam that into your calculator, and sure enough, it says that AB is 14.14. Now, if I get GeoGebra to answer that question for me, if I go from A to B, look at that. AB, 14.14. Boy, does that work slick. All right, so there's your law of sines. Now, another thing I'd like to look at is the measure of the arc. Okay? All right, so here's a triangle. Again, drew up in GeoGebra. Now, I've got the measure of the angle. As I move this point around, you can watch the measure of the angle change. Now, the measure of the angle in this case right now is 57.34 degrees. The measure of this inscribed angle is 57.34 degrees. That means the measure of this arc from C to D is twice this. So the measure of this arc right here is going to be 2 times 57.34. That's how you do this. So as this angle changes, now if I could get it to come down here to something close to a 90. Ooh, that's pretty doggone close to a 90. If I was to put a segment from there to there, notice that had I nailed that at a perfect 90-degree angle, this hypotenuse now of this, what should be a right triangle, does in fact go through the center of the circle. Now you have a half a circle. This 90-degree angle intercepts an arc that is 180 degrees. It's half the circle. All right? So that's how this works, okay? So the measure of this angle and this intercepted arc, there's a relationship. The arc is twice the angle. The angle is half of the arc, okay? Now, if it was a central angle, if I could put a dot right here on the center, and I'll put another couple dots out here on the circle, and we'll do a couple of segments here, like that. Now, what I've created is a central angle. Now, the measure of the central angle, okay, and what I'll do here is I'll rotate these points up so that you know that I'm taking up exactly a quarter of the circle, or 90 degrees, because you know that a circle has 360 degrees. If I could get that right on there. Darn close. All right, so you can see I've got something really close to a 90-degree angle here, and that is actually intersecting 1/4 of this circle. So a central angle intercepts an arc that's equal to the measure of the central angle. An inscribed angle, such as this angle over here, see my center point is tied to that line instead of the center. So it is equal to, this angle is half, twice the relationship, okay? If this is a 90-degree angle, it's going to intercept 180 degrees of the circle, all right? So this angle intersects an arc twice that angle. If this arc is twice the measure of the angle, okay? So hopefully that helps you out a little bit. That's going to be your video for the day. Well, actually, one of the videos for the day. And boy, I'm really starting to learn a lot about you folks. Those of you that are just kind of, scraping through here, doing the assignments because you're copying right off the notes, turning them in. God, they look great. However, when it comes time to using this stuff, there are several of you out there that are turning your check for comprehensions in with triangles that have 400 degrees. So that tells me you really don't know anything. So I would encourage you, please take the time to at least learn the basics of this material, and it will help out. So, all right, we'll have another look at that for some of you that are still struggling with that, measure of arc and how to find the length of a side using the law of sines, and get those check for comprehensions turned in. Today, I want to move into the rest of Chapter 10. I want to do Section 5, 6, 7, and then wrap up that because we got to get through Chapter 11. All right, so that's sort of the plan for the week. I give you guys lots of time to get caught up. You should be caught up. There's going to come a point in time here where I'm just not going to go back any further, and that's just going to be where you stand. Okay, keep up the good work for those of you that are working, and those of you that are not, please get on the program. All right, Mays out.